What's up, my sad stars? Let's look at a tough problem that a lot of kids struggle with, and I'm going to try to make it as simple as I can. So here is a probability distribution for a game. Now, when you play this game one time, you can have a score of 0, 1, 2, or 3 points, and the appropriate probabilities of each of those outcomes is listed. And this is, of course, a discrete random variable because our outcomes are whole numbers and they're very much listable. Now, let's let a new random variable, x, be the sum of 2 plays of the game. So we're going to play the game twice and add our 2 scores together. Now, the one really important key thing is that the 2 plays of the game must be independent of each other, which means what happens on the second play of the game has nothing to do with what happened on the first play of the game. Now, the first thing we got to do is figure out what are the outcomes for x. So that's the first tricky part for a lot of kids. So for example, I could get 0 points. How do I get 0 points? Well, I get 0 twice. That stinks. I could get 1 point. What has to happen for me to get 1 point? Now, this is what we got to really think. To get 1 point, I could get 0 the first time, 1 the second time, or 1 the first time, 0 the second time. So there's 2 different ways that I could end with 1 point. And processing that is hard to do, but it's really going to help make this problem a lot easier. Now, another example, you could get 6 points. So there's only one way that can happen. You got to get 3 the first time, 3 the second time, and that's it. You get your total of 6 points. But what about 5 points? Well, we could get 2 first and then 3, or 3 first and then 2. So there's definitely 2 different ways of doing that. So let's actually look at the probability distribution for x, the sum of 2 plays of the game. So here are the different ways that we could get 0, 1, 2, 3, 4, 5, or 6 points. Again, x being the sum of playing the game twice. There's only one way to get a 0. 0 the first, 0 the second. There's 2 ways to get a 1. 1, 0, or 0, 1. There's 3 ways to get a 2, because you get a 1 and then a 1, or 2, 0, 0, 2. Now, some kids will say, but what about a 1 and a 1? But wait a minute. There's only one way to get a 1 and a 1. You can't reverse and have it look different. 1, 1 is 1, 1. That's it. But you could get 2, then 0, or 0, then 2. Those are distinctly different outcomes. Now, there's 4 ways to get a 3. 3, 0, 0, 3, 2, 1, 1, 2. 3 ways to get a 4. 2, 2, 3, 1, or 1, 3. 2 ways to get a 5, 2, 3, or 3, 2, and then 1 way to get that 6, 3, 3. And you can say, well, what about 7? Well, that's impossible. None of our different single game scores could possibly add up to getting a sum of 7 over 2 games. Now, the next problem is, how do I find the probabilities for each of these outcomes? Now, to find those probabilities, I have to go back to the probabilities of each of the individual outcomes. So for example, to get a total sum of 0, I need 0 and then 0. So that'd be 0.2 for the first 0 and then 0.2 for the second 0. Multiple plays of the game, I multiply 0.2 times 0.2 or 0.04. It's that simple. Now, how do I get a 1? Well, again, that's 2 different options. 1, then 0. 0.4 times 0.2 or 0 and then 1, 0.2 times 0.4. Now, multiplication, 0.2 times 0.4 is the same thing as 0.4 times 0.2. The order you multiply does not matter, but these are 2 distinctly different outcomes. So I could do 0.2 times 0.4 plus 0.4 times 0.2, or I could just do the multiplication once and double it because I know there are 2 distinct outcomes. Let's show that for each of the outcomes that are possible for x. So here are the final probabilities. Now again, look what I did. For example, 0, I need 0, 0. 0.2 times 0.2, 0.04, only one way that can happen. Then I have 1. Well, how do you get 1 point? 0.2 times 0.4, but there's 2 different ways because I could do 0, 1 or 1, 0. But again, multiplication of 0.2 times 0.4 is the same either way. That's why I doubled it, because there's 2 distinctly different ways for that to happen. Then for 2, we got 1, 1, 0.4 times 0.4. 2, 0, but there's 2 different ways that can happen because I get the 0 first and the 2 second. Multiplication doesn't matter, but it's a different way. 3, I could get 3, 0, or 0, 3, so I times it by 2, or 1, 2, but that could also be 2, 1, which is why I times that by 2. 4, I could get 2, 2, 0.1 times 0.1, or I could get 3, 1, or I can get 1, 3. Again, there's 2 different ways to do that, so I multiplied that by 2. 5, there's 2 different ways, 2, 3, or 3, 2. But again, multiplication, they're the same. And then 6 is only one way, 3, 3. So for a lot of students, this type of problem can be very difficult because you got to first figure out what are my possible outcomes. You got to really be able to walk through the different possibilities when you have the first game and then the second game. And then the other thing that makes it kind of difficult is being able to calculate the probabilities of those outcomes. So really just walk through it. What has to happen? And just understand that you could get a 1 and then a 2, but that would be different than a 2 and a 1. Even though they both end up with 3, they are distinctly different possibilities. So just take your time, be careful, and really practice these types of problems because one is bound to be up on the exam. All right, if you need any additional help, check out the Ultimate Review Packet for AP Statistics. It's got everything you need to practice these types of problems. That way you could do good on your tests in class and on the AP exam in May.